All right, we're going to continue. We're going to do one more argument here and show that it's valid or invalid using indirect truth tables. And this is going to be number 14 from this same second set of exercises that we've been working on from 5.5. It's a longer problem, as you can see here, but it's the same technique every time. And this problem will be illustrative of one remaining aspect of doing indirect truth tables that we haven't seen thus far. So let's follow this closely. We always begin in the conclusion by making the conclusion false underneath the main operator. So we ask ourselves, how many ways are there to make a dot false? Now, we might recognize with some sense of dissatisfaction, I guess, that in fact there are 3 ways to make a dot false. And so that could mean a little bit of extra work on our part. So here's what you're going to do when you're confronted with a conclusion where there's more than one way to make that conclusion false. You're simply going to choose one of the ways to make it false and then hope it works out for you over here in the premises. So in other words, we could choose true on the left, false on the right, false on the left, true on the right, or both false. And in any of those instances, we would get false underneath the main operator here, underneath that dot. Having said that, I will give you a piece of advice. What you want to do before you choose one of the ways to make the conclusion false is you want to look at your premises, and unless your premises are just rife with tildes, right, I would choose a combination here that makes this false where you have some true in it, because it tends to make it easier to make the premises true. We do have one tilde with a bunch of, one premise with a bunch of tildes in it, but mostly we don't. So I would recommend in this one to start with true on the left, false on the right, or vice versa. Having said that, bear with me here, because we are actually going to start with false on both sides. And the reason I want to do that is because I want to kind of show you what happens as a result, right? What happens when it doesn't work out here for you? What do you do then? And so we'll see that. So L is false and G is false. We'll go ahead and plug those in over here. All right, and I think I got all my L's and G's there from the conclusion, found them in the premises. Technique now, of course, says to make all of your premises true underneath the main operators. True, 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 and true there as well. So we want to start with the easiest premise to work on. And again, that can be not easy to determine, but I will at least recognize this. If the G is false right here, I know the tilde will be true. And of course, that tilde is what's going to be feeding into the horseshoe. So now I've got true on the left, feeding into the horseshoe, right? And so we might think, okay, if I want this to have the happy ending I'm aiming for, right? If I want this to be true underneath the horseshoe here, that dot, the dot, of course, is feeding in from the right. What does the dot have to be, if anything? Well, if we make the dot false, you've got true horseshoe false. True horseshoe false is not true. That would screw this up, if you like. So we better make sure the dot is true. So that's nice, right? We know the dot has to be true. Now, how many ways are there to make a dot true? Well, what do you know? There's just one. Both tildes, right? It's going to be the tildes that feed into the dot there. Both tildes must be true to make the dot true, to make the main operator true. Well, if both tildes are true, then the H and the I have to be false, right? So the H and the I are false, and you know what? It's kind of a bit of a bonanza here, right? We now know that H and I are false. We go and find those and plug them in. So we've got H is false. Okay, there's not an I. It wasn't quite the bonanza we might have first anticipated there, but at least we got something out of it, right? H is false. We want the horseshoe to be true. What if we made J true? No, we don't want to do that. If we make J true, that's not going to happen, so we have to make J false. Find the J's. J is false. Well, let's think about this. J is false. We want the wedge to be true. If K was false, that wouldn't happen, so K has to step up here and be true, which makes the wedge true. So we've learned that K is true. And we're down fairly quickly to our last premise. K is true. K is feeding in from the left-hand side into our horseshoe. So, what do you know? We already know we have false feeding into the dot there. Now, as you'll know, or at least remember, anytime you have false feeding into a dot, that dot is false, right? M here is useless. M can't do anything about it. The dot is false, and that false is then feeding into the horseshoe. And so, of course, what we're looking at here in this third premise is true horseshoe, false, which is not true. Now, let's go back to our handout, right, which says, in this instance, we are to continue until we're able to make all the premises true or we get a contradiction, which, of course, is what just happened. Then we go to step 7. If there is more than one way to make the conclusion false, so we remind ourselves, yes, in fact, there was more than one way to make the conclusion false. So what do? Oh, and you get a contradiction of the premises. We need to go back and try the other possibilities for making the conclusion false. So we cannot at this point declare that this is a valid argument, in other words. We have to investigate whether, for example, we need to, that this might work, right? In other words, this combination, make the conclusion false, might make all the premises true. And if this one didn't work, we'll then have to investigate this combination, right? So just to be clear, if none of these three combinations of making the conclusion false work, if we get a contradiction in every case, then finally we would declare this a valid argument. But until that time, we've got to investigate each possibility here. So we'll investigate this one next, right? And so what we're going to do here is we made the conclusion false. We have L is true. Where'd my L go? There it is. And G is false. G is false there. Okay? And then we're going to make all the premises true underneath the main operator. Like so. And I know when people do a problem like this and they realize you have to try some other combination here to make the conclusion false before you can declare it's valid or invalid, you know, there can be some frustration, a little bit of extra work. But again, the way I would put it is we get to do it again, right? So just tell yourself, hey, I get to do it again. But I know that doesn't really work. But understand as well that it's not like we have to do the whole thing over again. There will often be a lot of overlap, or basically call it a rerun here, because look what we're doing here. G we said was false. G was false last time. So if G was false, we knew the tilde was true. If the tilde was true, we knew that the dot had to be true, right? This is all repeat. That meant the two tildes had to be true, which told us that the H and the I had to be false, right? All of that plays out in exactly the same fashion as it did before because we're starting with G being false. Now, we won't get as excited, or at least I won't get as excited about getting this bonanza of H and I here because we know it's just H, and H turns out to be false. And guess what? That's exactly what we saw before. So that means that J is false. And you might be thinking at this point, well, we know we're going to get a contradiction somewhere, but we have to play it all out here to see if that actually happens. J is false. J is false. That meant that K had to be true. K is true over here as well. Ah, but here's the difference. Last time L was false, and that made the dot false, which screwed this up or ruined it for us. This time L is true. So can we make the dot true, which will give us the happy ending that we're looking for? Well, we can. If we make M true, the dot will be true, which makes the horseshoe true. And so as we know from the procedure, if at any point in working on this problem we're able to get all true premises and a false conclusion, we know the argument is invalid. All right? So there are lots and lots of these problems to work on in your text. You'll see more on the practice exam to get you ready for the exam coming up on this material. So definitely work through all of those and follow this procedure. In the next video, though, what we're going to do is adapt the technique a little bit or change it so we can find out if sets of claims are consistent or inconsistent.